But this is sensitive data, credit card numbers, social security numbers, medical data, or whatever you think is sensitive. If you're an architectural and an engineering firm, the blueprint may be your class 1 data. To a software company, their source code may be class 1 data. So you get to define what it is. Class 2 is sensitive, but it's not regulated. Meaning there could be some embarrassment to the company if it got leaked or breached, but by no means is anyone going to be filing lawsuits against you, or is the FTC going to be coming after you if the data got breached. Everything else is class 3. If it doesn't fall into these two categories, it's class 3. Simple classification, right? How do you handle this data? So the premise is that class 1 data is always processed in controlled zones. Never in the cloud. You can store it in the cloud, but only after it's already been protected. But you never ever decrypt it in the cloud, you never process it in the cloud. Now there are lots of things going on in the field of cryptography. I'll mention it towards the end, where you may be able to process encrypted data in the cloud, but it's all experimental technology right now, and it may be many years before it will actually get productized, but there are possibilities for that down the road. Class 2 can be processed in secure data, secure environments, but you can store the data anywhere you want, because remember, it's only embarrassment. There's no sensitive data over there. Class 3 data can be processed and stored in the clouds completely. So let's take a basic web application. Here's a simple browser, a user getting ready to buy something and interacting with a web application server. All of the details of the transaction go to a single web server. Let's forget about scalability and all of those things for the moment. All of the transaction goes into one single place and it comes back to the single browser. There are companies that have specialized to the point where now payment processing is done outside of their application. So a variation of the same architecture is that you do all of the customer-related transaction in your application, but where you're doing the payment processing, credit card transaction, you essentially redirect to the payment processor of choice. And there are hundreds of these companies out there who will give you their API and their SDK and web service calls that you can seamlessly integrate into your web application so that the user never even knows. I mean, for all you know, you're buying stuff, but the payment processing is happening elsewhere. Unless you're looking at the URLs, you don't know this. It's all seamless. What does an RC3 architecture look like? It looks like this. You have a control zone. Now, because this is our presentation, obviously our product is in there, but it doesn't have to be our product. Any key management system, encryption and key management system that is capable of doing what I'm going to be talking about, you can substitute in here. The web application is written in such a way that when the user begins the interaction, they need to authenticate themselves. You authenticate to a controlled zone, implying that the user credentials and the authentication is happening in an environment that you have full control over. All data that you deem to be class 3 data, public data, is automatically transferred and processed in the cloud directly. But when you get to the point where you're doing sensitive data, as you're going through the e-commerce transaction, for example, the browser is automatically redirecting the transaction into the control zone where the web application is receiving it, processing it centrally in a controlled environment in accordance with the security policies, principles, and controls that you've established, and then only the encrypted or the tokenized information is transferred into the cloud. Now, if you actually went into the cloud database and looked at it, you should not see anything in there that you can associate with any particular individual, any particular price, anything that's sensitive that could be associated with anything that might breach a regulation. All of that is in your controlled environment. Now, what percentage of your data will be in the controlled zone versus in the public zone? It depends on your business, it depends on your data, and it depends on how you've classified your data. In some cases, it may be as little as 2 to 3%. If you're an e-commerce person, then maybe yes, it's only the credit card number, it's the price, it's the email address, and that's it. Or maybe some people may choose to encrypt even more. In a healthcare environment, here's how it might look. And I'm going to step through this in the presentation, step by step. Sensitive data goes in PHI, personal healthcare information, goes into the controlled or regulated zone, including things like X-rays, MRIs. They get encrypted but stored in the cloud. And all of the processing is distributed. For a manufacturing company, blueprints might go into the controlled zone and everything else gets stored in the cloud. So all of these things are possible. So let me step you through the process here of how an e-commerce web application might begin. I've already spoken about the authentication part that happens to the control zone. So passwords are here, they're hashed in there. The user, when they connect up to buythis.com, are going to authenticate to the web application running inside the DMZ of a controlled environment. Once they're authenticated, then the application may redirect into the public cloud to display all of the products or whatever it is that they choose to display, a search engine for finding things, and they start collecting information on the transaction. When it comes time to do the actual payment part, the browser, once it collects the information on the form and you click submit, instead of going back into the cloud, it's a redirect into the control zone. And this is all transparent to the user. The user never sees any of this.
Charlotte, I have to admit I'm a little confused by what you're trying to tell me here. So you've got, in this scenario here, this person, same company as the enterprise that you're talking about?
No, this is just a customer.
Okay.
It's me, it's my wife buying something at Amazon.com.
So from the customer standpoint, okay, all right, trying to figure out what you're considering the cloud here.
If I was an e-commerce company,
Okay.
I would write my application in 2 parts. There would be a part that would handle all of the sensitive data, and I would keep that under my control.
I guess part of my problem is I guess I didn't really think of e-commerce as cloud.
And that's because it's always been risky to think of them as being in the cloud, right? Because you've got credit card data, you've got transaction details about individuals and what they buy that you may not want to be visible.
Have you applied this concept or framework, or referring to things like software as a service or platform as a service, those types of cloud infrastructures, or is this strictly e-commerce that you're thinking about this?
No, we've characterized this architecture for e-commerce, for healthcare, for manufacturing applications, but there is nothing that says it cannot be characterized for software as a service. But the thing is, if it were software as a service like Salesforce, for example, you would not be in control of the application.
Right.
That's the difference. The assumption that we're making here is that if you're using RC3, you are in control of the application, that you have the ability to write the application with that architecture. Now, it's entirely possible that Salesforce may decide, oh, this sounds interesting, maybe we'll use this architecture. But they won't, because they manage their own cloud. But take an example like Netflix that went completely from a private infrastructure to the cloud. They're going through the transition where everything is slowly getting migrated to Amazon. But I was at this presentation yesterday where their Cloud Security Manager, the last slide he had up there was a wish list. And that wish list was